Hi everyone. Sorry for the delay in getting started. So this is the Med lecture. So welcome everybody, and thanks so much for coming and coming along and listening to the lecture. So we might as well just get started. So just a little bit about me first. So my name's Michelle. My name is Michelle, and basically, we'll do this whole lecture together. And if you have any questions at any time, there's a Slido link which we'll talk about in the next slide as well. I'm currently at Med at Monash, and I'm in final year right now, so UP to that, nearly done. And a few fun facts for me: I'm in the constant need of pens, especially when you're in the hospital as well. My pens just disappear. Like I blink. This morning I had a pen in my pocket and then I blinked and then it was just gone. So I really don't know where all of them have gone. And my favorite fruit is a watermelon. So let's talk about this. See, sorry. Um, Okay, amazing. So, just a couple of things before we get started, I guess. So, one of the more important things is we just wanted to talk about the uni notes. So the uni notes program is something that we've launched kind of only this year, and kind of getting introduced to that by the lectures here. So essentially what our uni notes is you've heard a lot about HR notes, and I'm sure you've seen all the great resources we offer there. So we're here to offer you heaps more of free resources so that you can thrive, and enjoy university as well. These free lectures kind of perpetuate our mission from our 800's mission to provide lectures and provide support, and it's just extending to help provide support even when you're in university as well. So it just wants we just want to make sure you're supported from high school to university to even beyond that. So there's a lot of different things that are on offer here. So you can find basically everything that you really need to kind of get started and hit the ground running. So that includes some study notes, subject reviews, so you can know that you're picking the correct subjects to suit your needs. And we've also got heaps of videos, heaps of newsletters, articles to kind of guide you through the university process and any curriculum which might come up. There's also a really awesome discussion space which helps guide you through the it gives you kind of a space for everybody to talk about and everybody to discuss their subjects, and for people from different universities as well to compare their subjects which might be similar, like doing biomedicine at Monash or doing biomedicine at Melbourne, and comparing which one, the differences and the similarities between both of them, and also just gives an opportunity for people across one subject or one course to kind of connect as a community. So we'll have a couple books on offer in the very near future, and I'm sure you've seen the 800 notes books, which correspond to the ones that we do during VCE, and we're hoping to publish these kind of a corresponding uni notes books. So please stay tuned for the updates on these books, which are going to be published, and these are written by, once again, top students who have aced their units, aced their subjects. So do keep tuned about this. And in terms of how to keep in the loop, just make sure to go to uninotes.com, and you can sign up and make sure you stay subscribed to the newsletters, and also follow our socials for any exciting updates. Cool. All right. So you already know about me, which is great. So in terms of the Slido Q&A, that's what we're going to be using here. And the Slido is going to be very, very useful so we can just figure out. So it's a bit more interactive and I can find out what you guys want to know and um, all the burning questions you have. So please do ask as many questions as you'd like. If you see a question which is similar to yours, please feel free to upvote it so it gets answered more quickly. And there are no silly questions, and you can choose to make the questions anonymous or non-anonymous, however you feel more comfortable. So do feel free to ask any questions, and anything happy to answer, from like the process of getting into medicine, any of the content included, the experience as a clinical or preclinical student, and even kind of my brief insight into the world beyond that. So, we'll start off with a slideo. I can get it up. So, let's do this. So, oh, it hasn't changed yet. Don't know if you guys can see that. Was that? Okay, let me make sure. Let's see. Okay, cool. So, let's just open up the poll for everyone. So hopefully you all can see that, and that looks good. Okay, so oh, that doesn't look right. Sorry guys, but that doesn't look quite right. Oh yes, it does look right. Sorry. So to kind of kick off the passion and kick off the joy, let's have a look at which resources you guys are most interested in. So, so we've got in. So you can show the results. Oh, great, amazing. So just get a couple more people to vote. Maybe what resources you're most interested in. Okie dokie. All right, let's see if some more questions. So, okie dokie. All right, so then let's go into our next slido, maybe, and we can show the results. Oops. So, what courses are we in currently? So I can see that everybody who's here is has done it as an undergraduate course. So that's good, great. So that means that you're probably looking to start to do it as a postgrad, which is amazing. Or I might as well move on with the slides, I think. All right. So in terms of the lecture itself, what's going to be going on is we're going to be just talking a little bit about applying for med, which I'm sure will be of interest for most people who are just coming into medicine and want to find out the different pathways, including postgrad and undergrad. And then we'll talk a little bit more about ethics and med law, talk about the population health, and talk about global health as well. And then we'll do the third block, which is talking about biochem, anatomy, and pharmacology, and then block four, which is talking about clinical skills. So amazing. Okay, great. Just for time's sake, we might skip past this one. So, in terms of the med admission process, the general admission process will be essentially we start with an academic score and then we have a test which is focused on your potential to learn. Regardless of what test you do, it's more or less focused on your ability to kind of retain knowledge or build from logic, ability to learn after that. And then the last stage of that is just an interview. So the academic score itself, it will either be your ATAR or your WAM. So your ATAR if you're going from high school into undergrad, and your WAM if you're doing another course or you're coming from. So it will be this is for kind of domestic students, so students who are interstate or from the same state. For international students, a little bit different, but similarly, you will require some type of academic score, whether that be like an IB score or an international equivalent of the one. And that's plus or minus. Some schools will have formal applications or questions which are just specific to that school. And if you need to do that, essentially all that needs to be done is we need to make sure it's people apply for it and that you have to fill out. Normally it's questions like why do you want to do medicine? What's your perspective on blah blah blah, or it might ask you about a social issue which you want to write a kind of a response to. Other types of questions can also be like, what is an experience that in your lifetime you think you'll never forget, or what's an experience that you think was really important to learn from? And those types of questions, I think that the University of the some of the New South Wales universities used to do a lot of those types of questions. Bond University used to do a lot of those types of questions. So it kind of just depends on which university you're looking at. But some will just use kind of the your core things that you're kind of doing throughout the year and just combine those. Some will require specific applications directly to the university. Okay, so in terms of the potential test, there's the UCAT or the GAMSAT. So the UCAT used to be something called the UMAT, which was decades ago, but essentially both of them are looking at the potential. The UCAT is even more potential based than the GAMSAT because the GAMSAT requires some scientific background knowledge, and kind of writing essays, doing that background knowledge part as well. So it requires some prior knowledge to sit that test. It's also quite a bit longer than the UCAT test, in terms of the number of questions and the time length as well. So just keep that in mind. And the last process for basically entry to any medical school is the interview component, which is focused on having it can either be an MMI, so multiple mini interviews, or it can be just like panel based, so you sit in front of a panel, or it can be one-on-one based as well. So couple different scenarios. In Monash, it is MMI, so multiple mini interviews. And essentially what that is like it's at 10 or 12 minutes per room, and you go in, they talk to you about a scenario, ask you a question, and you kind of just tell them your perspective on it, and you answer a couple of questions that they might pose to you. And they think about it and mark you based on that. A panel interview, a more common type of question is, why do you want to do medicine? It's kind of more general about getting to know you. They also might ask some scenario questions as well, like in this scenario, what would you do? But otherwise, they're normally longer overall. So they're normally like half an hour to an hour compared to the mini mental, which is not mini mental, mini multiple mini interviews. And because the multiple mini interviews, you normally have I think either yeah, you have about eight, and when you go through the process, that kind of amounts to an hour and a half overall. So overall, the same amount of time that you're kind of spending with the two things, but the panel interview, you're kind of just there for the straight hour, just talking with the same people, compared to the mini multiple, which you're just talking one on one with a person. I've also heard of interviews where it's just an hour just talking with one person as well. So that's completely possible as well. But there's a lot of interview types, and there's a lot of interview training as well in terms of what things you want to say, how you want to portray yourself. But I guess just as a kind of preemptive tip. It's just to portray yourself as yourself, because they are really good at determining whether you mean things or not. So just talking a little bit about medicine at Monash, that's just how the selection occurs. It will different things will different apply to different schools. So for Monash, it was one third, one third, one third rating in terms of the each of the different components. I know some places which weight the interview as 50% of the overall score. So it just kind of depends on what school you're looking to go to. But the selection process in most places will go that you have the academic score and then you have the potential score, and then those two are combined together to select people for the interview. And then once you're successful into the interview, you can kind of progress and get into the course. So tips for medical admission, you want to decide early whether you want to do postgrad or undergrad, and that way you can decide to do the UCAT or stress later. So because the UCAT is also a big responsibility, especially during VC where you're doing a lot of study and you want to decide early, oh, am I going to go through that route or that route? Another thing is when this doesn't matter if you're undergrad, postgrad, you have to decide whether you want to go to interstate or international, because a lot of those ones might have different requirements, like the answering of questions that I talked about before. And essentially, you just want to be careful about not missing any deadlines for any of those, because often if you miss a deadline, you have to wait another year. And obviously, another year of not being in a course or another year of doing something else might not be something you're looking for. So just make sure to look into it early and decide what university am I willing to, where in interstate, where internationally I would be willing to go for university. So another thing is make sure to get a good study group to go through the GAMSAT and UCAT questions, because sometimes they are a bit ambiguous of like what the correct answer is, and one person will say the correct answer and you can kind of pick their brain about why they chose that answer and the reasoning behind it. And your ATAR/WAM is just one segment of the selection criteria, but remember, even if it's only that one section of the selection criteria for medicine, it's really important for your everything else. So say you go through and you get a great WAM. Say let's consider two different scenarios. Say you go through, you try hard, you get a good WAM, you spend a little bit less time on your GAMSAT, so you do a little bit worse, but then you don't get it, let's say. So you still got a good WAM. So you can there's a lot of opportunities from there, which are postgrad courses, which kind of open up because you've gotten a good WAM. Compared to that, if you had the same scenario and you focused really, really hard on your GAMSAT and you your WAM was not as great as you wanted it to be, in that scenario, if the same thing happened and you didn't get in, it would kind of leave you in a worse position in terms of trying to get into other courses as well. And during the interview, like I said, try to keep calm, be professional, be calm, but try to get through a bit of your personality as well, because they will see that a lot. Right. Going to check back for any questions. Any questions? Okay, cool. No, no questions. Amazing. All right. So then, in terms of the medical structure itself, the number of years in medical school does vary quite a lot, depending on whether it's postgrad or undergrad, on between states and between places in general. Generally, it's about 4 to 7 years, and the 4 to 7 kind of depend on whether you do it purely postgrad or purely undergrad. So the 4 years will just be the postgrad component of the medicine course. It doesn't really account for the undergrad part. So between 4 or 7, just pure medicine school. And in the first 1 to 2 years, there'll be preclinical years. So they'll either be campus, online, or hybrid, so half online, half on campus. And those will mostly be focused on learning the basic sciences, learning anatomy, learning the basic ethics and laws around medicine, and kind of just building that really good base that allows you that type of thinking going into kind of clinical school, right? And then in the next 3 to 5 years, you'll be going into the clinical years. So this includes going to hospitals, going to community practices, etc. And these focus on just kind of providing you real life experience of what goes on in the hospital, provides you real patient contact and kind of the opportunity to do that. Cool. Alright, so block two, we're going to start just talking a little bit about the content. I'll just check if there's any questions. Has no questions at all. Okay, no questions so far. Yes, fair enough. We haven't really been talking about much content yet. Okay, so kind of talking about med ethics and med law. So med ethics and med law are just topics that you'll see all throughout medicine. Like you'll see it from probably the first year you go into the last year you come out. And you'll have ongoing tutorials, even in the clinical years, to kind of remind you of these principles. And you'll likely have to kind of discuss different viewpoints that talk you'll in these tutes or in these classes, the goal is to kind of debate different points and consider different aspects of things. So you'll also see a lot of medical lawyers or doctors with special interests in bioethics. And why that's useful is because you kind of get different perspectives from different people. That enables you to kind of learn a little bit better and understand the different considerations that go into making a medical decision, or the different laws which surround patients to both protect them but also protect you as a medical professional. So we'll just talk a little bit about the principles of ethics first. So there are four main pillars of ethics, and you'll see this throughout your medical education, that the four main pillars are beneficence, non-maleficence, autonomy, and justice. Cool? Right. So when we talk about each of these, we mean different things. So I try to represent these using the pictures, and they're exactly what you can see in the pictures. So let's talk about autonomy first. So autonomy is focused on people's choice, the people's right to choose their own paths. Okay, it's defined as the patient's right to be self-determining or act in accordance to their own reasons and values. And why that's important when we're talking about reasons and values is because essentially we want them to be acting according to their own thoughts. So often a scenario which comes up when we talk about autonomy is talking about a patient's ability to choose or refuse a medical treatment. And ultimately, because there is that principle of autonomy, according to ethics, by nature, if a patient chooses not to have something done to them and they're fully aware of all the consequences, but they feel like that's just not the suitable thing for them according to their values, then we have to respect their autonomy and focus on giving them what they want. But on the flip side, it also doesn't mean that we are just here just to provide things like if they say I want A, you give them A. If I want B, you give them B. We also can we can choose to offer things or not offer things, but they can choose to accept or refuse, essentially. The second two principles are kind of tied together. So they are the principles of beneficence and non-maleficence. So they kind of sound like a bit like tongue twisters, but essentially all they mean is beneficence is focused on kind of trying to benefit others, right? So we need to act in the patient's best interests and we need to act on the behalf of the patient and what we believe would be in their best interest. So if somebody was quite sick and in hospital and had an infection, we would think the best thing to do in that aspect would to be provide some medications for them because that would be in their best interest. If especially if this person was young and fit and otherwise didn't really have any problems, we definitely would think, okay, they really can't make a decision for themselves because say they've already fainted or are unconscious, and you think, okay, it's probably in their best kind of interest to do it this way. Non-maleficence is kind of that flip side to it, so it means doing no bad, and it conveys the obligation of do no harm. So that's a main thing in one of the principles of ethics. So the idea of we cannot do harm, and this is probably even more important than the principle of beneficence to not do harm, because a lot of things innately in medicine will have harm attached to them, like any medications you give, any procedures you do, anything really, like there's gonna be a risk with anything done in medicine. So our goal is to limit the possibility of that risk occurring and limit the possibility of bad things occurring in the future, essentially. More specifically, obviously we cannot be like guarding a patient off to try to get try to protect them from everything in the world, right? But the principle of non-maleficence is essentially just saying that we want to prevent any preventable harms, or we want to stop any preventable things from happening to this patient that we could have stopped or that we could have kind of lessened the impact of. The last principle here is something called justice, and there's two components to this justice. There's something where we think of justice as the scale, so everybody needs to be treated with equality, and everybody needs to be treated so regardless of their race, their age, their sexuality, their social status, their wealth, their religion, any factor in their life essentially except for their health status, and sometimes that can also not that's also important not to discriminate against, but in most circumstances their health status and kind of their their problems according to their health are the only things that we can really consider. We cannot talk about any social characteristics of a person as influencing us whether we are going to give medications or not give medications, or whether we're going to help them or not. So that's the idea of justice. And then there's that kind of subcomponent of the idea of distributive justice. So distributive justice is focused on making sure people get equal share of what is being provided. So for example, if you were going to the fridge and you just got an ice cream for yourself on such a hot day and you got nobody else an ice cream, I feel like people would be quite unhappy with you. So it's important that everybody got an ice cream because it equally there might have been 10 ice creams in the fridge, and you said, okay, I can get one for each person. And as long as it was possible that there was enough resources, enough things to do that, then according to the principle of distributive justice, we need to make sure to give ice creams to everyone. Cool. Alright. So then we have the idea of informed consent. So these two concepts are probably the concepts which come up the most repetitively all throughout your medicine life. So I thought that they would be important to cover now, especially because they're assessed and you talk about them quite a lot. So, the idea of informed consent is done from day one and is super important for any healthcare related profession, whether you go into being a doctor, being a nurse, being a physiotherapist, being a pharmacist, being an allied health professional, being a dietitian, like it doesn't matter what career you go into, anything health related in in the healthcare sphere will require informed consent. And the components of informed consent are three parts. So they must have capacity, it must be voluntary, and it must be informed. Okay? So let's start with the informed part because that's probably in the name. So, informed means that we must tell them enough information for them to be able to make a reasonable decision. So, they must be able to know why something is being done, what effect it will have with them, what risks it might be attached with, and what benefit they might reap out from it, and along with kind of the long term, like, is there anything else that could have been done to replace the thing that's being offered? Right? Voluntary is focused on being that it's free from influence from others or coercion, which is otherwise known as coercion. So you can have internal coercion, which means you are influencing yourselves, and that can occur when people have voices in their head or have things going on in their own body which are trying to force them from doing something, force them to do something, sorry. And then we also have external coercion as well, which is when other people are trying to convince that person to do something. So often this can be unintentionally family members who are trying to just help along the patient in hospital, and unintentionally they've coerced them into doing something. The last component is capacity, and this is super important because capacity just basically equals to the ability to make the decision, right? For for in Australia, everybody above the age of 18 is considered that they have capacity automatically unless they prove otherwise. And then people under the age of 18 can do different things to kind of prove their capacity. So in order to be able to be competent enough to make a decision and be able to kind of use your use your thoughts and use your values and apply your values to making a decision, which is the principle of autonomy. You must have capacity. So the components of capacity, there's four components. You must be able to retain. So if I said to you, now, what are we talking about? What's the importance of beneficence? And you and I tell you, okay, this is why it's important, you should be able to retain that. You should be able to understand that. So if there's any language barriers or anything of that similar nature, then they kind of fail the step to understand. The next step after that is to be able to weigh. So you've gotten all this conflicting information. You must say to yourself, okay, what do I think is better? What is better in the risk benefit ratio? And then the fourth part is be able to communicate. So you've weighed it and you say, okay, I want this. You need a method to be able to say, I do want this one, not that one. And that doesn't necessarily have to be verbal, it can be written down or anything like that as well. Cool. Actually, we'll go back to the slide here. So what is not a principle of ethics? Let's go through the slide here. Okay. What do we think? What is not a principle of ethics? Right, we've gotten some good answers. Great, good job, amazing, guys. So indeed, equality is not one of the principles of ethics. We are just focused on having informed consent. Sorry, we are focused on, if we go back to this slide, so beneficence, non-maleficence, autonomy, and justice. Those are our principles of ethics. So the couple those two things that I talked about, those are probably the most important part of the law and ethics part. In med law or the subject that's related to that, you won't be expected to be able to regurgitate the laws that often. Some schools may ask you to do some important laws like the law supporting informed consent or the law supporting an ability to make like if somebody has a mental health condition, then the ability to kind of override their decision sometimes because they're they might not be free from coercion because it might be internal coercion. So those are the two most important concepts, I think, especially when just going in, because they are things that get repeated over and over again. Okay, so let's talk about population and social health. So population is more focused on data and statistics and talking about how they influence kind of the way we deliver healthcare, deliver medicine in general, and how we can look at data and things from when we try out different medications and we look at the information and say, okay, that medication is better than that one, so we'll use that one, and how we can gather that data, look at that data, etc. So it's one of those topics that you'll be speaking through your whole medical education, and in fact, after you graduate as well, it will become even more important. And it focuses on talking about the health of the population and how the health of the population, therefore the health of the person, and how it can be improved and different things that you can use to improve it. So things like screening tests, like I'm sure a lot of you would have heard about like a bowel screening test that is nationwide. That's something that population health has been trying to gather data on and show that is effective because it helps prevent really, really bad diseases. In the later years, it will also give you the ability to look into research papers, and these research papers are things which might be look very, very long and look use very confusing terms, and that's why we need to kind of build our skills over time. And once we build our skills over time, we can look at that information and say, okay, I can synthesize from that information that this thing is important, and you can about it with your patients as well. Okay, so like I said, the most important part of population health, which is carried across from undergrad years, or sorry, from preclinical years into clinical years, is being able to talk about these statistics and data. So we'll talk about a couple different definitions of data, uh, and talk about how that kind of applies to it. So the first thing is true positives and true negatives. So true positives are people who have the disease who tested positive. So that means that yes, they have the disease and they were diagnosed by the disease by some other method and they've tested positive on the test. True negatives are the people who don't have the disease but tested negative, and why we want a true negative is because we want to make sure the people who don't have the disease aren't being said to them, oh, yeah, you actually do have the disease. So that's just going to give people a fright and make people really anxious and nervous about it. So we want to make sure we have a high percentage of true positives and a high percentage of true negatives. And that's where the concept of specificity versus sensitivity comes in. And it's really easy to mix up the two things and think, okay, I'm just going to pretend that they're the same thing and kind of mix the two up. But it's important that you know the difference. So, sensitivity, how I think of it is how sensitive a person is how easily they can pick up people in their region. So if you imagine a very sensitive person, I just imagine that they have like a radar on their head and they're able to pick up a really large radius of people because they can detect them really easily. So how we determine what sensitivity is we divide the number of true positive people with the total people with the disease. And that will give you the percentage of people with the disease who were found to be positive, which gives you the ability to kind of say, okay, so if I have a 70% sensitivity, that means that 30% of my people are being missed, right? That 30% of the people with the disease are actually being missed. And we can kind of extrapolate from that and say, that's not very good, and we need to develop a better test. Specificity is like the opposite, but twin of it. It's essentially talking about the ability to exclude people without the disease. Because, like I talked about before, if you told somebody without a disease that you have the disease and then later on went, just joking, not actually, they would be very annoyed and have a really big shock. So we try not to do that by trying to increase the specificity. So if we talk about true negatives over total without disease, what you're actually getting in as the bit which is left over is false negatives, right? And that's a even bigger no-no because we're thinking, oh, so we have true negatives who don't have disease, so we're happy with that. But then what about the people who actually have disease and that we said are negative? So that kind of runs into complications again. Okay. So the last two measures that we're going to talk about for pop health are positive predictive value and negative predictive value. So the positive predictive value is that the chance of an outcome that is given is going to have to be a positive result, right? So with a positive, so it's essentially the chance of somebody with a positive result actually having the disease. So remember the other one when we're talking about sensitivity, that was the total amount of positive people saying that the total amount which had the disease, right? Compared to this is the total positive over the amount of the people with the disease and positive, so true positives, over the total amount of positives, whilst the other one was over um, the total amount of disease in the population. And it works the same way for negative predictive value. So essentially what we're looking for is the chance of the diseases not happening given a negative result. And in fact, the negative predictive value is probably more important than even the positive predictive value. Because if we do a test on somebody and say, okay, so we've gotten the test results, they say they're negative, but how do we know whether it is negative or not if we don't know what the negative predictive value is? Because if you don't know what the negative predictive value is, you'll never be able to tell whether a result is reliable or not. Cool. Alright. Let's so if we want this all together, what we want to do is kind of seesaw this because as we increase specificity, the sensitivity will decrease, right? Because we're getting a higher amount of true positives in the test, and the other one is trying to increase the amount of true negatives in the test, right? So if both of those exist here, and we need to figure out a system to kind of balance out those two together. And there's not really a structured system on how we say, okay, this is going to work, but we just try and aim for at least 90-ish% for each of those, and we get to a balance eventually, which we can say, okay, that's fine. Um, I'm happy with that result of that test, and when I use the other test as well, it gives me the same result, so I'm happy about that. Right? So it's kind of just a balance between different things. Okay. So that's social determinants of health. Just going to quick check questions. Okay. Alright. So I'll just maybe answer a question before we go into the social what? Yeah, the social health part. So we have a question. So what kind of materials like notebooks, folders should we get for our first year undergrad med? Are there particular materials which helped you study? Yeah, so I really recommend that you get so notebooks are really useful. You'll see with a lot of classes, but it was even like pre-COVID where a lot of the classes were run in person. Even pre-COVID, like a lot of the work was done on computers, and that's because a lot of the old important resources are now online. So there's a couple of things that you'll hear about, including something called ETG and AMH, which you'll get introduced to quite early. They stand for the therapeutic electronic, which is the E, therapeutic guidelines, so ETG, and AMH, which is the Australian Medicine Handbook, and they're essentially all full of medications that you can talk about, um, and they're really good because they're online, they're really easily accessible. So I would say if you're the type of person who likes to write things down, I know in first year med, I wrote everything down on like a notebook. I wrote everything down on sheets of paper because that's just what made me happy. And it made me happy to see all my notes like that. So definitely something you can do. There's also something called Notion as well, which is like an online program which you can type and use in as well. I know a lot of people use like their iPads to write on, but I would say you overall, the most amount of worksheets you'll probably get are during the tutorials and during like the workshops, which are kind of focused. So the tutorials are like small group and the other one's like a big group. I would say with lectures, for most universities, it will be recorded, and if it's recorded, they're unlikely to provide you like handouts or anything like that during lectures just because of the amount of people who turn up and just too many worksheets to give out. So I would say you can basically bring whatever you want, like a notebook for like I would say depends what type of folder and depends like what you're going to try to do with that folder, like organize the sheets, that's fine. But I would say maybe just bring like one notebook, but you can kind of vibe it out whether you prefer using your notebook or your computer. But I would say definitely you have to bring some type of technology of some sort and maybe a notebook, couple pens. Um, yeah, I think that other than that, you don't really need to bring too much more than that. It's not very like you just need to bring yourself. There's a couple classes which you might have throughout the year which you do need to bring specific things for, and they'll tell you. So things like we'll talk about later during the lecture, clinical skills classes or skills which are focused on professionalism, which you're practicing your skills that you'll learn, like talking to patients and that type of thing. In those types of things, you might need to, I would say, buying a stethoscope is a good investment in general. So the stethoscope is for anybody who doesn't know, it's like that thing where the thing that you wear, which like connects to your ears, and people listen to your heart using it. Um, I would bring up a picture, but I'll show you a picture once the lecture is done. I'll just put it up on the screen. But essentially, it's just like a steth. It's just the thing that people use to listen hearts and lungs and all that wonderful organs. But I would say that is a worthy investment to make because you will use it during your clinical years. You will use it when you're a doctor as well. So it's like quite expensive. So they're like 100, 200. They can go up to like 400 or something. Don't get one which is too fancy. You probably don't need it. But just get one, like a good basic one, a good sturdy one, and you'll be quite set. I would say you can probably delay buying that until at least halfway through first year med though, because you probably won't start doing any of the hands-on type stuff until that time. But you know, by all means, I think that's a worthy investment to make. But yeah, I think technology, a step at some point. You might need to bring a like a lab coat in if you have any lab classes, just to make sure your clothes don't get dirty. And if you have any dissection classes as well, we don't want anything getting on your clothes or and we also want to make sure everything is clean as well. So that type of stuff and then you can bring like notebooks, notes, whatever you really want, and that will help just kind of get the stuff done. But yeah, and any particular materials that helped me study. So I think the best thing that will study, honestly, is people who have gone through the course and the materials that they produce. So a lot of universities will have peer programs, and in those peer programs, they'll be able to provide like revision resources and things like that, which really supplement the lectures. And another thing is the tutorials are normally structured so they help you revise the things you learn in lectures. And why that's good is because essentially in a lecture environment, you're just sitting there and trying to absorb things. But in a tutorial environment, it kind of gets you to think about different things which might be going on. Um, but most importantly, I think materials which helped the online website, so AMH, ETG, are really helpful. For anatomy, there is so much anatomy resources out there. What I would recommend most is get a really good anatomy book, right? And they will be, it will be amazing. You will love it. You will be happy. That will be your like life goals. And get some anatomy flashcards as well once you start learning anatomy, because those are seriously so good. They just help you revise, help you actually go over the things, help you see it visually. And there's a lot of 3D models of anatomy online which you can kind of dissect, move different things around, see how different things interact. And those are super useful as well. And there's also something called Teach Me Anatomy. There's also Teach Me Surgery as well. And those two websites are absolutely amazing because they help explain things and help talk about different structures in the body. They help talk about problems that can occur with the structures, so you can talk about those as well and kind of relate it to how you might see it in a person. Um, Other types of materials that helped me study were, I would say, like all those like different timers. So it doesn't really matter what technique you use, but I feel like a study timer is good because you'll find that things can get a little bit dry sometimes. You have to like break up your study quite a bit. And otherwise, I would say, oh, things like, so a lot of people swear by something called Anki, Anki, and people like it. I haven't used it terribly much, but I feel like if you can get used to making, it's like a flashcard system. So the idea of Anki is you do a flashcard and it's supposed to give you spaced repetition. So you do one flashcard and then you say, okay, I'm happy with it or I'm unhappy with it. And based on your response, they either delay when they give it back to you or they give it back to you straight away, depending on how much you want to learn it and how comfortable you feel with it. So I feel like that's really useful, especially if you get start using it at the start of the year. I definitely didn't use it during my pre-clinical years, but once I went into clinical years, I used it quite a lot during, especially third and fourth year, because it was really helpful. But I think if looking back, it would have been a useful resource regardless, and especially for medications, because it can be really hard to remember medication names, what they do, because it just doesn't associate in your brain. It's so different to the other stuff you've been learning so far. But yeah, flashcard apps as well. I used Quizlet for my flashcards, so I didn't use Anki. But Anki, I feel like if you can make your own flashcards and get familiar with it early, it's really good. Cool. Alright, I'm going to tick this one. Okay, I'm going to answer that other question later. We'll talk about social. Ooh, just press something. We'll talk about social health and then we'll get back to it. Okay, so um, two things before of so social health is the last thing we'll talk about without breaks. I'll maybe talk about this and we'll take our break. Okay, so social health is kind of the other half of the coin. So population health is kind of looking at how we can better the health of a population from a quantitative type of perspective. So what are the statistics? What is the evidence to support putting in something new and how do different things affect people's health? And we can look at the numbers on that. Social health, and we in our one it was called human knowledge and society. So different people, different schools will have different names for this, but the concept is the same. Essentially what you're looking at is how somebody's health is impacted by their social circumstances and how their social circumstances can impact their health. You'll get probably a whole glossary of terms which you will interact with and learn, but we won't delve into those ones because it's just more memorization and using it in conversation. But in terms of the structure of the classes based on this, you'll have lectures on it maybe, and you'll have also small group tutorials on it as well, just to kind of discuss the issues. Because just like the ethics and law, social health is a lot of the kind of small group activities. They're very focused on you expressing your own thoughts on it and expressing the complex, what you think is impacting a person's health. So this is kind of the bubble that we see quite a lot. So it's kind of a person's health is influenced by core factors and then it gets influenced by other things as well. So if we just try and talk about one of these factors here, right? Let's say we talk about education and how we're educated, because that's really important, right? Because right now we're trying to be educated in something. So, in terms of education, somebody's working conditions and education. So somebody's education, right? If we get good education and supported education and we are able to go well during our schooling, we are more likely to get employed, get work, go to university, etc. Right? If we have a supportive environment where we can kind of pursue education, we're more likely to get work and kind of get higher order work as well. So work which might require which requires training or which requires a university course or a TAFE course. So something that requires learning before you go into it, because often those jobs will be a bit more higher paying than those jobs which don't really require any pre-knowledge going in, right? So this will affect our socioeconomic status, right? Because with those higher paying jobs, we're more able to support ourselves, more able to kind of support our living circumstances, our living environment, right? But then this socioeconomic, so our ability to finance, especially in like Australia, where we have a public-private system for healthcare, that's going to impact our ability to access health, right? Because if we have more money, we're more likely to be able to access both the private and the public aspects of health, right? So that affects our health. But then if we think of it in as a cycle, if initially a person was of, and if we think of like this person and let's say they had poor socioeconomic status and then for poor health, and that kind of impacts. So there you have poor health, right? And poor health can then kind of spiral into not being able to work as much, which kind of exacerbates the situation of not being able to earn enough money to sustain your lifestyle. And then that might go on generationally because now that person might not be able to support their child in pursuing education, might not be able to provide them enough financial support to pursue the education or enough time at home that they are able to say, I can support you for so you can go to TAFE, go to university, go to whatever you want. They might not be able to do that. And that kind of spirals into the next generation of people. So you can see that there's a lot of to talk about, and you could pick any aspect of this and you can talk for ages and ages on it. And you can also look at like issues in the media and issues kind of just any health issue in general. And you can just talk a lot about why things are occurring and what's going on, right? And you can kind of debate back and forth about what's the most important thing, what's the chicken, what's the egg, essentially. Cool. Alright. So we'll move on to biochem. So biochem is mostly focused on a lot of the biology topics, which you if you've done biology before, it does make your life a lot easier in terms of the topics that you'll have to do. But if you haven't done bio, a lot of them will have the bio bridging course, and or you'll have it done during your undergraduate course, so you'll have some background knowledge going in. And stuff like this includes like cells and tissues. It includes protein transcription, translation, and kind of expression. It includes the ATP scale, includes microbiology and immunology as well. So let's just talk a bit about cells. I'm sure this diagram seems quite familiar to you. So if we just talk about the different things on the cells, we can be talking about, so this was like literally my first day, my first lecture. She showed us a cell, and asked us what all these different things were and what they did. And all I could think of was mitochondria is the powerhouse of the cell, because I was so tired from the holidays, and I just looked at the diagram and I was like, oh, this is giving me like flashbacks to biology and going through cells. So if we look at all of these different structures here, right? So we can see that that's the mitochondria, the powerhouse of the cell, which produces ATP, which is really important for us to have energy and to provide the energy in our cells for whatever we really need to be done. And it's also quite important because it does play a role in keeping our electrolytes, which is the salts in our blood, balanced. We'll also have these vesicles up here, which might be containing things, fun things, and we also might have lysosomes, which contain even more fun things, which degrade other things. If we look here, we're going to have the Golgi body here, which is like the post office of the cell, and that's what it packages. And then we have the smooth endoplasmic reticulum, which is important for lipid synthesis and lipid kind of packaging. And then we have the rough endoplasmic reticulum, which rough for all these ribosomes attached to it. And remember, that's what helps package the proteins once they're formed and helps actually form configurations. Otherwise, we just have long strands of random amino acids, long strands of patterns which can't actually be folded together. And obviously, ribosomes are those little things which help you form where the proteins are. And then we have the wonderful nucleus and nucleoid, which so the nucleus is the outside area, and the nucleoid is the space which actually contains all the DNA and wonderful things that make you you. And essentially, that's where protein transcription will take place. So just keep that in mind. And essentially, it helps us do everything. It writes the script. It tells us what to do, right? Right now, every one of us is using our DNA to do various things, lots of wonderful miraculous things, right? Another thing with the DNA is it will have, so another thing about the nucleus and nucleoid, the DNA within that, the two strands of DNA, there are things which turn on and turn off, kind of like switches. And the switches within the thing, the combination of switches which are turned on and off will kind of form what the function of the cell is. So, for example, if this cell was a muscle cell and it helped you run, right? The thing that helps form all the mitochondria and helps it do that would be switched on because they're saying we want lots of mitochondria so we can be powerhouses of the cell and then we can power other things as well so that we can run around, do what we need to, climb monkey bars, etc. Live our lives, climb things, be active, walk across campus, you know, those types of things. You don't need to know about like plant cells. It's kind of irrelevant, just animal cells, because humans are animals. So that's why we just need to learn about animal cells, not plants. Types of tissue, this may be familiar to you, maybe not, but essentially the focus is on kind of there's four main types of tissue, and what we do is there's connective tissue, epithelial tissue, nervous tissue, and muscle tissue, right? Connective tissue, like the name suggests, connects different things together. And it can also include fat tissue as well, because that kind of forms strands between different things and holds them together, right? And some diseases affect connective tissues, right? So there's something called Ehlers-Danlos, ELHER hyphen DANLOS. Not something you definitely, not something you need to know at this point. Something cool about it is it affects the connective tissues of us. And what it actually causes is because there's connective tissue everywhere in our body, it actually affects the heart and causes heartbeats to kind of balloon out and causes really bad problems. If you can imagine the artery, like our blood vessels kind of ballooning out, that's not a good thing, right? And another interesting thing is that it can cause like bluing of the white parts of your eye as well, and also cause hypermobility. So your joints and stuff can like flip over. People can dislocate their own hips, etc., etc. So quite a cool, oh, not a cool disease, but a very interesting disease, and it's all because there's a defect in the connective tissue. Another disease that is similar is something called Marfan syndrome, Marfan. And in that syndrome, once again, you get something, so it affects the connective tissue, so it really affects the big artery coming out of your heart, and it's pretty bad for that. And it can also cause issues with the gut as well. And it causes these people to be, on average, a bit taller than other people and have really long joints as well. So very interesting things, and they're based on this type of tissue. Then we have epithelial tissue. Epithelial tissue is basically the tissue that just lines everything. So your epithelium is like the epithelium of the body is basically your skin, right? Because it lines your body. And there's something called endothelium, and your endothelium is the lining inside of your blood vessels. So that can also get damaged and cause problems as well. Then we have muscle tissue, and muscle tissue, there's a couple different types of muscle tissue. So there's smooth muscle tissue and skeletal muscle tissue. So smooth muscle tissue, the appearance of them are slightly different, but smooth muscle tissue is essentially controlled by our body's autonomic system. So the autonomic nervous system is essentially the system that doesn't require us to actively think and do. So it helps us breathe, it helps us go to the bathroom. It helps us see. Helps our blood pressure be stable. Just helps us do a lot of things that we don't actively think about or actively do, right? So that's control. That's called the autonomic nervous system. And it kind of makes sense because it's auto, right? And the two components of that is the sympathetic and parasympathetic. So you might think of the sympathetic as the fight or flight response, right? So when you see a bear charging towards you, that's your sympathetic nervous system being activated. So you get a fast heart rate that allows you to run faster. Um, you have your pupils dilating, which allows you to see better, etc. And then you have the parasympathetic, which is the one which is rest and digest. That's the other name for it. So you're sitting, you're eating, you're chilling. That's your parasympathetic system. Cool. Okay. And the other one is your skeletal muscle, which is controlled by your somatic system. So somatic is basically the system which you actively need to do. So when I'm gesturing, moving my hands, moving around, I'm all using my skeletal muscle. And because even though I do not actively think I want to move my hand, when I move my hand, a signal goes to my brain to say, okay, she's moving her hand now, and that goes to my brain. And then I sense I want to move, right? So I say, okay, let's say I want to move my arm, it goes, the signal goes to my brain and then comes back down. Compared to an autonomic thing, like I do not actively have to initiate the movement, it will just happen inside of me. Cool. Okay, so those are the different types of muscle. And the heart muscle is a type of skeletal muscle, but it's a little bit different in terms of the appearance of it. But you would think that the heart muscle is completely made of smooth muscle, completely made of skeletal muscle. It's a little bit of a hybrid of both and it doesn't really look like either of them. But it actually is a skeletal muscle, and essentially what it is it has like an activation system, which is like a kind of auto loop activation. Okay. And then nervous tissue is your neurons, the things that help you think, help you move, help you do things, the things which connect your hands to your brain to say, okay, I'm moving my arm now. Cool. All right. So in terms of transcription and translation, there's a process called nuclear expression, right? So I would think that this is something also that you'll probably just memorize and learn at some point, but just to go through the process, we have, and this will also be useful if you're doing any bio-related subjects in general. But essentially, we have this first step here, right? And this is where we have this unlooping of these two strains, right? The strains break apart and kind of unfurl because they were wound together before, right? So this RNA polymerase, right? This RNA polymerase, some type of thing here, will bind to this section, bind to a section in the DNA, and it will help this unfurling, and transcription factors will come along and be helpful little elves and help it unwind as well. So then what it does, the RNA polymerase binds to the promoter region, which is the region which is saying, hi, hi, come bind here. And then it moves along the template strand and it reads it from a 3 to 5 direction. Now, one side of the thing is 3 and one side of the amino acid is 5. I would say you don't necessarily have to know it very, very in detail, but just knowing that it it can go from 3 to 5, and it's named that way essentially because we need to name it so that it has a 3 and 5 cap end, so we can know which end to put which things on, right? So it does it in an anti-parallel fashion. So it reads it from 3 to 5, but it makes the strand from 5 to 3. All you have to remember from that sentence is essentially that it binds to it and it forms a complementary chain. So it just does the opposite. And you will have heard something like ATCG, so adenosine, tyrosine, and then cytosine, guanine, right? So those kind of amino these bases bind together and they just paired up depending on which one it is, and you just need to find its pair essentially. So then it moves until it reaches the end of the gene. And at that point, there'll be a termination sequence being like, stop, stop, stop. And then it will release something called a pre-RNA. Now, I thought pre-RNA was the full name of what it was. It's actually something called a preliminary mRNA. But essentially, this preliminary mRNA will be complementary to the template strand that's formed. And it'll be the exact same as this coding strand, which is the opposite strand to the template strand, except the T and U will differ depending on whether it's RNA or DNA. And then what will happen after this, before it moves to out of the cell into the translational phase is we'll have introns sliced out. So introns and exons are essentially just segments in the DNA. So the introns are the things which are included, exons, sorry, are the ones which are extra and they are just taken out, right? And then we have this, so if you can imagine like segments and then taking out, it now becomes a lot shorter. Now, remember that 5N and 3N we were talking about before? So we add a cap to the 5N, so we think of the 5N as like the head, so we add a cap to it and add a little tail of poly A. So that's literally A. That's what a poly A tail is to the other end, so to the tail end, right? Okay, so then once this is made, now we have a mature mRNA which can move out of the cell. And this mature mRNA will then go to this translational cell. And this translational cell essentially just helps us find out what's going on. So it it reads this mRNA, right? And then it attaches to those ribosomes which were on the rough endoplasmic reticulum from before, and it will start reading at the 5N, and it will start reading, and once it gets to AUG, the start codon, it will start reading and pumping out this protein chain. The really important thing is the start. You don't need to memorize the start codon, definitely not, but essentially you just need to know that there's a certain code which starts the production. As it reads, so a codon is 3 letters in a DNA sequence or an mRNA sequence. So it's like AUG or AGC or whatever, right? Like it's 3 letters, and those 3 letters, there will be something called a tRNA, right? And this tRNA will come over like a little fish, and if it matches that mRNA sequence, it will attach on and then release its amino acid, right? And it does that every single time. And when the amino acids are together, what they get done is they bond together. And by that way, we're kind of forming a chain of amino acids. So we get the tRNA, it forms the bond with the side, it releases, it lets go, and it also lets go of the mRNA as well. So it's not a permanent binding, it's very temporary. So we can kind of see it being done here. So you see how it kind of comes along, the tRNA, oopsies, the tRNA comes along, it binds, it leaves, it binds, it leaves, it binds, it leaves, it binds, it leaves, etc., etc., right? Cool. So this goes on and on and on. And by the way, that little segment on the tRNA is called the anticodon. On the mRNA, it's called a codon, and in the DNA, it's called a triplet. Okay. So then it gets coded, coded, coded until we reach a stop codon. So a sequence of DNA where it's like stop, 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 right? And once we get to that, this polypeptide chain, which is that chain of amino acids which are being bonded together, will now just break off. And it will be released into the wild. And once it's released into the wild, then it will go to the rough endoplasmic reticulum and get folded and packaged, and then might get sent out of the cell, used within the cell, and etc. Cool. So now let's talk a little bit about immunity and microbiology. So the types of pathogens that you'll mainly need to know are bacteria and viruses, full stop. I added prions in there just for fun. There's like a famous disease called mad cow's disease, or I don't know how to pronounce the other name, but it's like I think, is it German or something? But essentially there's something called mad cow disease, and just for fun, mad cow disease is it was from cow meat, that's why it's called mad cow, and it caused these cows to behave really abnormally. And the people would eat the meat of these cows, right, as you do, and then they would also eat these prions. And prions are basically just misfolded proteins which wreak havoc. So once this prion meets another protein, it causes it to be folded in the same way. So it's kind of like infecting other proteins. But we really need proteins in all of our bodies. So once it affects multiple things, it affected primarily the things in the brain. And because all of the proteins were changing to this random prion which doesn't do anything, it was disrupting all the function in the brain, and people unfortunately passed away from that. But it is a really interesting disease. Like most diseases are quite interesting and quite unique. The main two you'll need to know are bacteria and viruses because they're common, there's a lot of them, right? So bacteria, they're prokaryotic organisms, which can be commensal, which means it helps the human body, is ready in the human body, or can be disease causing and can secrete toxins and invade tissues. Viruses, on the other hand, cannot live without a host, so it's not alive, right? And it just goes through this cycle of it binds, it duplicates, the uses the nucleus to form its own proteins, and then it duplicates, and then it forms little vesicles, and then buds out and explodes the cell, and does lots of wonderful things that way. Some viruses live within cells their entire life. Some viruses just like escape into the wild, into the bloodstream. Other things that you might come across are called protozoa, which are eukaryotic organisms. They're things like worms and that type of organism. Um, there's also fungi, so fungi can also cause problems. Yeah, so like the mold you see growing can cause quite nasty disease, especially in people who don't have great immune systems. Okay. So, in terms of lines of defense of immunity, we'll talk about a couple of things. So, the biggest line of defense for your body is you're going to be your skin, your beautiful intact skin. Okay, if it's not intact, it's no longer a line of defense, and it prevents pathogens from physically getting on there. And also, there's a lot of like things on the skin as well, like enzymes and acids and stuff, which actually are not great for growth of bacteria. So that's why it's really good. Another thing that's really important in the lungs is the mucociliary elevator. So the mucociliary elevator is essentially like the cilia are little like hairs in your like in your breathing tubes, and they kind of like beat. And then you have mucus, which is like sticky stuff. So if you think of it, a bug sticks to the mucus and then it gets beaten out. It's kind of like a vacuuming system, not vacuuming, more like a what's called a sweeping system, right? Like it sweeps all the gross stuff outside. So then once you cough it up, you can either swallow it down or you can just get it out of your body, right? And if you swallow it down, the stomach is pretty good at like killing things. So it's very acidic. So once it gets down there, the bug will probably die, but which is good for us, right? Because we don't want bugs in our body. In some diseases, this can be quite impaired. So there's a disease called cystic fibrosis, which affects the lungs and it can affect a lot of other body parts as well. And what happens in that one is the mucus and that just becomes so thick that the cilia, because they're little things, they do not have enough energy to beat things out. So it just stays there, festers, gets even worse, and causes really bad problems. Cool. The next one we'll talk about is this beautiful stomach here, which which I said just then about how acidic it is. So because it's so acidic, it's really good at killing most bacteria. But there is some bacteria which live here quite well, uh, including something called H. pylori or Helicobacter pylori, and that's a really famous bacteria because what so fun fact about this bacteria, the person who discovered it gave himself an infection with it and then tried to treat it to prove that it was causing him his stomach problems. But essentially it's this type of bacteria and what it does is it kind of neutralizes that acidic environment so that it can live with it. So it still cannot deal with the acidic environment, but it has mechanisms to kind of help it become less acidic. And then in crying and saliva, there's enzymes which break things down, really good at breaking down proteins and that type of thing. So if you ever cry and then somebody's like, "Is everything okay?" You can be like, "No, I'm just killing all the bacteria on my face, and that's why I'm crying." So it's, it's a good way to get an excuse for it. Another good thing is our lovely back like gut and lovely skin and lovely everything bacteria. There's a lot of great bacteria which help us be more healthy. So whenever we get an infection or anything like that, often the bacteria which are there already kind of fight for space and say, nope, you can't grow here. We're already using all the resources. Another really good thing about these is that it helps you like they might secrete stuff as well which make the environment not very welcome to other things trying to grow into it, so that's really good. But on the flip side, if our body has too much of these, they can also cause problems in the long term. And whenever we like have antibiotics, we basically kill off all of our healthy bacteria, or at least a good portion of it. So that's a bit unfortunate. So the last type of thing is in terms of our hair, we have a lot of oils and sebum and lovely stuff which kind of protect from bacterial growth, right? So yeah. And then we also have, so with this one we coughed up, and this one in the urinary tract we kind of just get it out, right? Just goes flip flop and out of our body. So in terms of the lower half, we always try to expel things out as well. That's why if you get a tummy infection, your diarrhea is good because that means you're expelling the bad stuff out. Okay, in terms of the second line of defense, the second line of defense is non-specific. So essentially, what it does is it sees anything which doesn't look like itself and it's like, nope, you out of here. So what it does is the main function of a lot of these is being a phagocyte. So a phagocyte, phago is like eat, site is like cell, so eating cell. So that's exactly what it does. It just eats other cells, and then what it does is it like engulfs another cell and then puts lysosomes, which are like enzymes and toxic things, into the cell and kind of breaks it apart, right? And then once it breaks it apart, it can like spit it out into the bloodstream to kind of get rid of it because now it's just broken parts. The Some of these are a little bit different. So these are mainly involved in like allergic reactions or parasitic reactions. These two, so the monocyte and the neutrophil, these are the major phagocytes. Macrocyte is a little bit better at connecting us to the next line of defense as well. Neutrophils not so much. They're really sad cells because they're like the first line of they're like the first on the scene and the first to die. Like they get there, they eat stuff, then they expire. It's really sad. So all of the pus you see is actually made of neutrophils, which is really tragic because they fight really hard. And then we'll have lymphocytes as well, which are part of the third line of defense, and we'll talk about that a little bit later. But there's also factors like complement factors, and there's cytokines, which also are really important for our second line of defense as well. Cool. So in terms of our third line of defense, we have the B response and the T response, right? So the T response is focused normally on things which are intracellular. So if we have bugs inside cells, that's what the cytotoxic and T cell response focuses on, compared to the humoral response, or the things that involve the B cells. That more focuses on things which are extracellular, things that we can attach to, right? So what happens is we have an antigen presenting cell, like a macrophage or dendritic cell, and those are just two different types of cells. And essentially what it does is it's just like it goes to its leader and it's like, I'm showing you, here you go, look at what I found, right? And then the thing that finds it will be like, oh, that's not good. So then they'll try and recruit people which can fight this thing. So it will recruit people, and then once it finds the correct recruit, it will like duplicate them so that we have a larger working force. This applies for both the humoral and the cytotoxic response, so the T and the C response. The difference is that the T cells, what they basically do is they're like armed killers. So they attach to the cell, they inject poison, inject things which melt off their bones, and then they inject that together, the cell dies, or the thing inside the cell dies, and then it kind of scraps it away. It's the type of cell which kills the cell in order to kill the thing inside it as well. So it burns down the building in order to like get the person inside of it. Compared to that, the B cell is it produces these things called antibodies, which are these little things that we see here. And essentially, what it does is it pumps those out, those attach to cells, and kind of say, here, here, to the neutrophils and the phagocytes from before, like, here, here, come and eat me, I am here. And then kind of flags it to the system, right? And then you'll have something called memory B and memory T cells. What they do is that's the whole idea behind vaccinations, because what's happening is we once you get vaccinated, the bug's antigen kind of gets introduced to you, and you're like, okay, I know where that is. So the idea of that is that if we have these memory cells around, the system doesn't need to go through that whole process of again of trying to find that cell. It now has a large variety of that cell, so it can directly like make it's more easier to mount an immune response after that. Cool. Alright, we'll go on to our slideo, which is which of these is part of the third line of defense? And I'll just check if there's any questions as well. Yeah, so, okay, so which of these is part of the third line of defense? What do we think? Right, we're getting some great answers so far. What do other people think? Cool, awesome. I completely agree. How do I do that? Okay, yes, I completely agree. It is indeed a cytotoxic T cell. Really good. All right, so now we can answer the question. So we might move on. All right, so we'll just talk a little bit anatomy and then we'll talk about clinical skills. And then I think we have a really fun activity coming up. So anatomy, this is probably what the bulk of your learning will be uh, in the later half of the year. And essentially, you'll get to do some type of dissection or cadaver work. And it's a really how do I, what was it? It's a really uh, privileged, that's the word. It's a really privileged position because these people are volunteering basically their bodies up for medical students to study, right? So it's really privileged that we get to see them and use them. So for that reason, and also for you to get as much out of these classes as possible, it's really, really good if you do some study beforehand, particularly just learning the terms and figuring out what's going on. Because in all of the textbooks and in all of the things, things will look different to what in your thought it looks like, right? So it's really important that you kind of first know what the most common type of configuration for, let's say, a shoulder or a hand in what like what's the most common type of things in in the hand and like how do they work and where do the vessels pass and all that kind of stuff, right? That's really important for you to learn um, early so that when you learn that in the hand and you've looked at a lot of pictures online, now if you go to a real hand and look at it, you're like, oh, okay, so I remember this goes through here, so I can identify that there. Because in a real person, right, everything looks the same, like the nerves, the blood vessels, everything looks the same. Because in our like in the pictures and in the flashcards, things will be like brown and blue and red. Like it's not going to be like that in real life, right? So you need to know your basic landmarks and terms. Um, and that way, if you ask the people who are doing the dissections with you and you tell them, oh, okay, I think this passes through here. I looked it up and I saw this there. They'll also be more willing to tell you, oh, yeah, yeah, absolutely. This is what's going on. You're right. Normally it does pass through here. This one's actually a bit different. And they can tell you more about it. But that's my top tip. You should prepare in advance, especially for anatomy classes. Uh, Make sure to be respectful during the process and ask questions about any structure you don't understand. So it's really important to ask early and don't be afraid to ask as well because a lot of the structures can be really confusing and it's really tightly packed together. So it's hard to know what's what. Knowing the anatomy, especially for the musculoskeletal system, can be really helpful for clinical skills part of the course as well, because you need to know the innervation of the nerve group or kind of what's going on to help you predict what's going to happen to the body, right? So, for example, if I injure this nerve, which helps control this muscle, what is it actually going to do, or what is this person going to complain about? So it really helps you, especially for musculoskeletal. and which are like bones, muscles, and the neurological system, so all the nerve system. Those two components, especially, knowing the anatomy really, really does help. Knowing the anatomy for other things, like it's important. Like abdo, like the vague position of the organ is important. But otherwise, like unless you're going to be doing you're in a surgery or something like that and you're looking at it, it's not that helpful to know like each specific detail, right? You just need to know key things and you retain that knowledge when you go into clinical years as well. But there's just those little key things are important to figure out first. Cool. So let's kind of, these are some concepts which come over again and again. And these also come up in like radiological things as well. So radiological things are like X-rays, CTs, MRIs, ultrasound. That's what radiology is, because in the old days it was purely based on radiation, right? So there's a couple of different planes, and each thing will be named a different thing based on what radiology you're taking. But it is useful just to know the planes in general so that you know what you're looking at. So we have something called the sagittal plane, and that goes all the way across your head. And how I kind of think of it is like, I'm not sure why, but like if I think of a sagittal plane, I think of like a Trojan, with the like little hat, not the hat, but the thing that like the little horse hair thing in the middle of their heads. And I kind of think of that, so it goes straight down the middle. If we think of coronal, right? This is your crown, the top of your head. So it has to go this way, and it's kind of like slicing. Oh, sounds a bit gory, but it's like slicing behind your face, right? So that's the slices you'll see. And then there's also transverse and axial, which is like going across your body like this. It takes slices like that. And it's really useful because if you want to say, let's say if we want to try and find a problem here, we might be looking at here and then we can find it here and then we can also find it here. And it kind of helps us form a 3D construction of the problem that's going on. And it'll be really useful when you look at CTs, MRIs as well, because it gives you a greater sense of what's going on. Another thing that will be important, especially for the bone muscle topic, is about movements. So, and about what is flexion, what is extension. So, the basic movements that we can talk about is flexion, extension, abduction, adduction, internal rotation, external rotation, pronation, supination, and inversion, eversion. Okay? Not all your joints will be able to do all of these. And in fact, I don't think there's one joint which is able to do all of those. But most of your joints will do, or what most of your joints will, all of your joints will do at least one of these. So flexion extension, what we think of, like there's something called the anatomical position. This is the anatomical position right here. So you have your hands to your sides and then your face standing face on, right? And all of the movements are based on the anatomical position. So if we're thinking of flexion extension, right? So flexion is going to be kind of coming, yeah, it's going to be like going away from the body, right? Or kind of feels like it's going towards the body. Flexion. Yeah, it's going towards the body, I guess. Yeah. So if you think of flexion, it's going towards the body, extension going out, and then flexion of the legs is going in, going out. Um, and that's extension. So that's flexion, extension. That's a paired one. Abduction, adduction. How I remember abduct is away from the body, adduct is towards the body. So if you think of these two hands being brought towards the body or away from the body. So abduction, abduction. Okay. So then you have internal and external rotation, and that's relatively straightforward. So you look at the part which is internally or externally rotated, and does it turn inwards or does it turn outwards, right? So that's how we work out that. And then supination, pronation, you really only see this with your hands because your hands are the only thing that supinate and pronate. Soup, you're holding a bowl of soup, okay? Supination, pronation, supination, holding a bowl of soup. And the last one, eversion, inversion. So the only context I've really heard this in is like your feet. So inversion, you're turning in, eversion, you're turning outwards. Okay, so the soles of your feet are facing outwards, and that's basically the the movements in a nutshell, but each of the joints will have a different set of movements. So for example, in your elbow, right, you are not going to be able to, because your elbow is like because of the way that the joints are connected, right? You're not going to be able to supinate and pronate. Oh, sorry, you're not going to be able to abduct and adduct, right? Because like your joint simply does not go that way. Like if you hold the top part here and try and move it to the side, it's simply not going to go that way because like there's no way for the shoulder. Compared to the shoulder, right? You can add abduct and adduct, like that's possible, and you can also flex and extend. Compared to this one, you can only flex and extend, really. So it kind of just depends on how the joints are connected and what movements you can do. Okay, there is also something called dermatomes, which are really nice and they help you like determine a lot of things. There's dermatomes and myotomes. So dermatomes is like sensation, what you can feel. Myotomes is like the movements you do. Search up if you have time and if you want to, the myotome dance. It's quite hilarious and a lot of fun, and it helps you remember the myotones as well. And dermatomes kind of just tell you, so these C1, C2, all that type of stuff is talking about the levels in your spine. So the levels in our spine start from C1. So that's for cervical, which we call the region behind our neck. And then we have thoracic. So our thoracic region is our chest region, right? And then we have our lumbar, which is our lumbar region, so the lower back, etc. And then we have the kind of sacral region as well, and that's to do with the essence, right? So essentially, for the upper arm, we focus mainly on the cervical spine because that's where all the nerves that control our arm come from. And you can see here that these nerves kind of section off certain parts of the arm. There's also going to be certain, so depending on what nerves you're talking about as well, there's going to be specific sensation areas as well. But it's really useful if we can, in a context of like a clinical patient, in a patient that you might be like, because a lot of the questions, even in preclin, they're focused on a patient does this, a patient does that, etc. So say if a patient lost sensation somewhere and then they had weakness somewhere, you could be like, oh yeah, I know that movement is done by the C6 nerve, and they're also lost, oh sorry, C7 nerve, and then they've lost sensation, let's say, okay, let's say for changing things up. Let's say they've lost sensation at the top of their arm, which is the C5 nerve, and they also cannot shrug their shoulders, and cannot kind of lift their arm at all. So what that's related to is the axillary nerve, and the axillary nerve kind of innervates this muscle up here. It helps you shrug shoulders, move your shoulders, lift your arms, etc. And the area here, if it has no sensation, that's also related to the C5 nerve, right? So it's kind of like two things are related in one, and you can kind of use that as your puzzle piece to what's going on. Cool. So let's try and put this into practice. So a patient presents to the ED after a car accident. They cannot feel sensation on their thumb. So which level of nerve is damaged? Let's have a look at the slide here. You guys are doing great, by the way. So what level do we think is damaged? It's a bit hard without the diagram, but I'm really quizzing you guys. So remember what I said about the majority of what controls the arm. Majority of what controls the arm is kind of related to our, yeah, so the majority of what controls the arm, remember that's very related to our cervical spine and our upper thoracic spine. So our T's and our C's. We'll just wait for maybe one more answer and then we'll move on. Okay, amazing. So in fact, the level which has been damaged here is actually C6. So if we flip back to the previous slide, so oh wait, yes, so C6, right? Because if you think of the thumb, right, it cuts off here, so C6 is the nerve which has been damaged. T1 was a really good thought and in completely in the right region. So T1 is normally the region here. How you can think of it is like C6. You can just so they're like sections, right? But there's like key parts on each dermatome, each level spinal level, which you can kind of remember. So what I remember is C5, C6, right, all the way up to your thumb. So C6, then C7 is your middle finger, C8 is your pinky finger, and T1, and then T2 is in your armpit. Okay, and that's all the nerves you like, all the spinal levels you have to know. For your leg, what I think of is like in the upper groin region, you're kind of thinking it's going to be like L3, like in this region here. It's going to be L3, and then the front of your knee is L4, right? And then what happens is the L5, it starts on the lateral aspect, which is the outside aspect, so the aspect towards the outside of the thing. So your medial aspect is kind of your center, so medium, middle, that type of thing. So that's the medial aspect, and this is the lateral aspect. So the things on the outside. So L5 curves from the lateral aspect to your big toe. So how I remember it is L3 is kind of your upper thigh, front upper thigh. L4 is your knee. L5 is your big toe and lateral leg, lower leg. And then S1 is your pinky, not your pinky toe, your small toe. Yeah, your small toe. And then from there, S2 is like the back of your leg, most of the back of your leg anyway. And then you don't really go anywhere from there. That's the majority of what you have to know. Cool. All right. Last part we'll talk about is clinical skills, and then we'll do something really fun. I think it'll be really fun to go through this actually. So clinical skills, essentially what it is it's probably the favorite topic for most medical students, especially preclinical, because it actually shows you doctorly things that you will apply to when you're in hospital. And it will be super important. This is probably not biased at all, the most important topic, right? Like your ethics, your law is really important, and it's important because you know the medical lawyers are there to support you, but you also need to know what is wrong and right. But this is probably the topic which, when you're thrown into the deep end and going into hospital, you will have to apply this knowledge so much. And this is also the topic where you'll build the knowledge the fastest because you'll learn one thing this week and then keep on building upon it in the following weeks. And you'll also learn examinations throughout the year as well. So, listening to people's hearts, listening to people's lungs, looking at people's tummies, etc. And also learn practical skills like doing injections, taking blood pressures, putting in drips, taking bloods, and you'll learn more of these over the different years. And you'll also learn how to take those like ECGs, which is like looking at the heart electricity. So, really big tips for this. Um, it's really hard to go out of your comfort zone and be like volunteer and say I'll do it, but ultimately everybody is there to learn. So really, really, I do encourage you to have a go, see how you do. Like if you have concerns or questions, you can always bring them up with the teachers or the people taking the classes, and be willing to have a go and try, because the only way you're going to learn these skills if you repetitively practice with others. And because these skills are very practical based, it's often really good to have a study buddy which you do this with, and you can like talk through the questions, do the examinations, do the kind of listening to the heart, practice those types of skills, right? Because if you don't really have a partner to practice on, it's hard for you to really reflect on what you're doing right or wrong. And you can practice with different people as well. And a really key skill in doing this type of thing is being able to use non-medical terms to explain things. So you can say something like, so a term that we use for a heart attack is called a myocardial infarction, right? Myocardium is basically, so we talked about endothelium, which is the inside of the heart. The myocardium is the muscle of the heart, right? Infarction is basically when you have like blood, the blood is not getting through there and there's damage to the heart as a result, or damage to the area as a result, right? So myocardial infarction is basically when we have damage to the heart due to a vessel being blocked off or blood not being able to get to the heart, right? In other words, it's a heart attack, right? So you need to practice the ability to, because you'll get so used to hearing myocardial infarction, that when you're practicing with your friends of kind of practicing asking these questions, you might say, ask them, have you had a myocardial infarction? In an actual patient, they will look at you like, what's a myocardial infarction? Or for some people, like it kind of varies with like patients. Some patients are like they know the terms because they've heard it a lot or they've had a lot of experience with it. Some patients won't. And it's just easier to use terms which everybody understands, just so your communication can be a bit more efficient and you can get your point across a bit quicker. So some of these assessments based on this will also be timed as well. So you, instead of saying, have you had a myocardial infarction before? You can just say, have you had a heart attack before? And most people will like be more accepting of the latter compared to the former, right? If you have any small group tutorials on this, please kind of like anatomy, make sure you read up on beforehand, or at least just like read through the things that might be going on. A really good site for this is Geeky Medics. They do really fantastic stuff. They're UK based, but medicine is medicine. It's the same everywhere. So just make sure you can have a read about them and like the steps they do, and they also have a lot of videos where you can see what's being done as well. So they're really good. So I would check them out in terms of the kind of practicing the skills. So one of the first topics you'll learn in clinical skills is something called history taking, and that's essentially just learning how to talk to a patient and get information from them in terms of why they've come and what their past history is like. So the key part of this is that you always start with a really broad question like, why have you come in? Like, what's brought you into the doctor today? Or um, why have you come to hospital? Or what's been troubling you? Like anything of that, any of the above is fine. It doesn't need to be specific wording. It can be really anything. And there's going to be a lot of like different ways this is taught, and it will vary from university to university, but there will always be a structure which is taught. So a really common one that I went with, because it's probably the most common one which is taught, is Socrates. The one that's actually taught at Monash is not Socrates. It's like WWQQAA BIC, so it's a little bit different. And that stands for like where, when, quality, quantity, associated features, alleviating, aggravating, beliefs, impacts, um, concerns, and expectations, right? So that's kind of the model that we use. And it's fine to use either, like, it's fine to use any model you want, but Socrates is probably the most famous one. So I thought I would just go with that one because it's probably the one which will come up the most. So it's very pain focused, unfortunately. But you can apply it to things which are not pain related. So first thing, site. Where is the pain? Like, where is the symptom? Like, say this person's like, oh, my leg hurts. Oh, sorry, that was definitely not your leg. Definitely not the leg. Let's say, oh, my arm hurts. Oh, it hurts so bad. And then you can ask them, or let's just say it hurt. Like somebody says it hurts, right? And then you can ask, where does it hurt? And they say, oh, my arm hurts so bad. Um, and then you can say, can you point to exactly where the pain is? And that helps localize exactly where the pain is. Because people might say, oh, my pain is here, but that doesn't really give you much information. Okay, onset. That's talking about how the symptom came on. So, for example, if we're talking about nausea or vomiting, we can say, did you suddenly like feel really nauseous, or was it kind of building over a couple of days? When did it first start? Is it on and off, right? Then character. You're talking about like how would you describe this pain, or how would you describe the nausea? How would you describe your tiredness? So just ask them to describe it. Radiation is to do with the pain, normally pain, like does it go anywhere else? So let's say my arm pain. Oh yeah, it goes to my hand as well. I get some like weird sensation in my hand, or my shoulder hurts as well. Like that's a radiation because it's coming away from the main pain source to somewhere else as well. Associated symptoms. So that word is terribly, terribly vague, but essentially what it is like, let's say I said I have my arm pain, and I said you say to me, "Oh, is there any other symptoms that you think you've been having?" And especially when you're beginning, people will be nice, and if you ask that, they'll be like, "Oh yeah, I actually did have this. I have some numbness, I have some weakness, etc." T for timing, and that's to do with like has it changed over time? Has it increased? Has it decreased over time? Exacerbating and relieving. So that's kind of like um, aggravating and alleviating, right? But what makes it better? What makes it worse? Severity, what you need to say to them is you can say, just rate it on a scale of 0 to 10. What we were taught is that you must tell them what 0 and 10 is. Because you might say, okay, what's 0 to 10? And they might be like 10. And you're like, so it's the most painful thing you experience. They're like, no, 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 I mean a 5 then. So you just need to tell them what 0 and 10 is. So 0 is no pain, or 0 is, say, this was for like vomiting. So or like for nausea, like 0, not nauseous at all. 10, you feel nauseous every moment of the day. You feel like you want to vomit, you have vomited, etc., etc. So that's kind of the idea of it. And Socrates is like forms the main person into play. So why they've come in today, right? But then because a patient is a person, not just a problem, right? You need to find out about what's going on around them as well. So things like their smoking history, their alcohol, what medications they're on, what medical conditions they've had in the past, their family history of medical conditions, what their social life is like, and whether they exercise, what they eat, if there's any sleep problems, if they've been stressed more than usual, what are their finances like, what's their occupation. So you can find out a lot of things, and so that you can get a bigger idea of that person, because we can go back to that idea of social health and that things around the patient also impact the patient. And a lot of the things like past history, family history, and the smoking alcohol stuff will also impact the types of diseases you might see in the patient. Cool. So, um, let's we've got a couple more slides, but essentially, let's just talk about putting it all together. So that's kind of like each little individual bit of content. And now let's talk about what you might see. So many universities will have case-based tutorials, lectures, big workshops like I've talked about before, and they try to have lectures which are based on the week and have like essentially a topic of the week or a system of the week or a body part of the week. And what they do is they talk about that body part and then they base tutorials or big workshops on it. And normally it's designed so that everything fits together quite nicely. Some universities do it better than others, unfortunately, and some will have lags, but that's okay. Like ultimately you have to learn everything anyway. So an example of a week of curriculum which fit together very nicely was we had a week which was focused on heart stuff. So we had a lecture on heart physiology, so how it beats, how it starts to beat, how it stops beating, etc. Um, then in our anatomy classes, we had dissections and looking into the heart and thoracic region and all the nerves and vessels that pass through there. Then our clinical skills was based on taking a heart history, so all the heart symptoms. And the following week was focused on doing a heart exam, so listening to the heart. And then our kind of med law and ethics and social and population was kind of focused on scenarios and interventions for people which are heart related, like doing ultrasounds of the heart, doing scans of the heart, and also how to consent patients and the idea of informed consent. Cool. Okay, so this is the part which I am very, very excited about. So hopefully you will all find this a little bit fun because I feel like this will be quite fun for everyone to do. So hopefully everyone can just ask questions. The questions are asked anonymously as well, so it'll be a lot of fun. But essentially, so let's go back to that Socrates process again. And I can, I'll maybe, hopefully you guys can access both of these at once, but maybe I'll feel like it'll be easier if you can see the wording around it as well. Maybe I'll just do this. Oopsies. Give me 1 second. I feel like it will be better if you can see everything. So, okay, move it into here. Okay, I'm gonna do that. I'm gonna just make the text smaller. Okay, let's try that from here. Okay, so hopefully you can see that all. I just feel like it'll be easier if you, yeah, if you guys have the answers. Oh, sorry, just like the acronym as well, because it'll be easier to ask questions. So normally, because in small group tutorials, I feel like this will be really fun to do. So let's do this question in Slido. So we have Mr. Cup. He's a 68. This is a really common type of question. This is probably the most one of the first types of like patient scenarios which you'll learn. We have Mr. Cup. He is a 68-year-old man who's come in to talk to you, his doctor, and to ask some questions. So, what is the first thing that you want to ask here, according to what I've been saying so far? So you can just put it into the Q&A because I don't think you'll be able to. Oh wait, I have a poll. I lied. But if I go to the poll, you can't see it anymore. Let me just activate the poll and then you can input the answers. Um, this one. Okay, what questions would you like to ask? That activated. I realized it didn't activate the other poll, so sorry. Okay, what questions would you like to ask? Okay, I'll go back to the other page so that you can, while you're typing, you can see what the questions are as well. Perfect. Really, really, really good. Okay, so where is the location of your cane? Point to it, please. Okay, so I'm gonna say, okay, doctor, yeah, I've just had this horrible, horrible, horrible chest pain, and it's just not going away. It's in the middle of my chest, so right here, I would say, but it's just so bad. Okay. All right. What other questions do you want to ask? Yeah, beautiful. So one of the questions that has been asked is, has it subsided at all? Like, has it changed? What's been going on with it? Yeah, so doctor, I reckon, yeah, that I used to have this pain as well, like, but it never used to be this bad. I used to have just a little bit of pain. I used to get a little bit uncomfortable, but it just went away when I sat down. Like, I was completely fine. But now, doctor, this has not gone away. I'm in so much pain. I feel like the world is ending. I'm feeling sweaty. I'm feeling hot. Like, I just cannot do this. What some other questions that you might want to ask? has it what has eased your pain? Really good, exactly. Oh yeah, doc, nothing has really made it better. Like I feel like an elephant is sitting on my chest right now. I just cannot deal with this. It's seriously so bad. Nothing is making it better. Nothing is really making it worse either, but like I am in so much pain. Maybe we'll get. Yeah, perfect. When has the pain come on? It's kind of bright. I'm like, oh wait, I cannot read. Perfect. So if so, often, let me just say, so where is location? We've done that. Does when has the pain come on? Oh, duh. It came on like an hour ago, but it's so bad. Like I swear, it's the worst pain I've ever experienced. Um, what habits, what habits do you have? Or what habits? Oh yeah, funny that you asked. Like I do not go outside. I'm on my couch all the time. I just sit there, do nothing. Um, Doc, I know it's bad for my health, but like I just cannot get up. Okay. All right. Do you smoke and drink? Perfect. Really, really good question. This is really important for this type of patient, right? Actually, Doc, you know what? I do smoke. I've been smoking for a number of years now. I've smoked since I was 18 because everybody did back then. And I smoke like 20 cigarettes a day. I just, I know it's bad, but I just can't quit. I do drink a little bit. I drink like a glass of wine or two with my wife at night. But you know, other than that, I don't drink that often. But I feel like I don't drink that much, I would say. Okay. All right. Any other questions? You guys are doing so amazing. Um, this is exactly the questions that you should be asking. Okay, so we've covered site, we've covered onset, we've carried character. I said an elephant is sitting on my chest. Um, we've covered timing, whether it's getting better, covered exacerbating, alleviating. What other things do you want to ask about? Yep, so really good. We've also had one on how severe is your pain? Perfect. Oh, doc, like I said, pain is 10 out of 10. I cannot deal with this. Seriously, I've never experienced this level of pain in my life before. I just, I need something to help right now. I just feel absolutely awful. Right. Um, is it 10 is unbearable? Perfect. Really good that you quantified it. What is yours on a scale? Perfect. Um, 1 is noticeable, 10 is unbearable. Yes, absolutely, really good that you guys are quantifying what's going on. Because once you quantify things, it just helps you kind of understand what's going on a little bit more. So, yeah, I would say it's a 10. Out of the scale, even, I would say it's 100. It's just so bad. I feel just so unwell right now. So, we've done one, two, three, four. Okay, so I'll give you all the last couple of details and you can try and tell me what you think is going on right now. So I say, oh, it goes up into my jaw and down my left arm as well, like in terms of the pain, just a little bit. It's not as bad as my chest pain, but it does a little bit. Uh, and then timing, it was really suddenly come on, like just bam, and then I was just in pain. Like nothing makes it better though. I am so done with this pain. Associated symptoms. I feel a bit dizzy. I feel a bit sweaty. I feel a bit puffy. That's how I feel right now. Um, yeah, and I feel also a bit faint. So I don't really know what's going on. Cool. So I'll give you also some other information about this patient. So they've had a blood pressure. They're on blood pressure and like kind of cholesterol medications, which are things that are like fats in your blood. Has been stressed lately. Like I said, I don't exercise, I don't really do anything. And his father had a heart attack at 70. His mother had high blood pressure, no siblings, no children. Okay, so what do we think is going on with this Mr. Cup? What does it sound like based on kind of like generally what you think this sounds like? Yes, perfect. Exactly. Cardiovascular disease, right? This sounds like something very heart related, very something. So I'll just show you this. And well, there is actually a couple more slides. Sorry. So this is just an ECG, which is that heart electricity. Do you see all these like jumping up bits here? That's not normal. That's something we call ST elevation, which is basically elevation of this region here. And that's not good. That indicates that he's having a heart attack of some sort. So definitely not very great. But you'll see these a lot more as well. Okay, just some final tips for success. Be organized. Like I said, make sure you keep up with your lectures, keep up with your assignments, do whatever you need to do. Get a buddy to keep you on track. And nobody's going to chase you down for anything in university. So just make sure you keep aware of that. Okay, find some good study groups and resources. So, like I said, Teach Me Anatomy, 3D modeling, Anki, they're all quite good. Study group is so important for medicine. If you have somebody you can study through, you can study with them for your entirety of medicine because you'll be practicing exams, practicing so many important things together. And don't forget that people in your upper year levels will more than likely run some type of peer mentoring because it's quite supportive and they will know what is very highly accessible, what is less accessible, and they will be your gold mines of information. And the third thing, like I said, especially in first year, just enjoy life, enjoy uni life, enjoy being on campus and kind of talking to other people. Really bond with your group if you can, and just make sure to connect and make the most of being on campus. Attend those social events and collect. There's a lot of societies and clubs which are med specific, and there's also lots of societies and clubs which are university specific. So do try and get involved in both because it kind of gives you a life both inside of men and outside of men. And it can be really overwhelming because you're suddenly going to an environment where you're learning a lot of information at a breakneck speed. So just make sure to kind of take time off and give yourself enough time. And most faculties, from my experience, will be quite they'll be quite nice about any time you need to take off because after all, medicine is about caring for other people. And if you can't care for yourself, how can you care for others?